Hello and welcome to part 4 of my Code It Yourself role-playing game series, and in this particular episode we're going to focus on items, inventory and combat. Now I appreciate this has been a long series and we've had a lot of code to get through, but I will reassure you all that I'm going back to normal routine once this series is finished. And I've had a number of people asking me for the source code for this series. Well, it will be being released, it won't be being released with this video just yet, and there's a reason for this. Right now it's just a collection of building blocks, role-playing game functions and classes with no particular cohesive game bringing them together. And what I'd like to do is release the source code in the form of a game, so you've got something you can play and then study how the code works, like with all of my other videos. Instead, what I think I'll do, and you're more than welcome to join me, is I'm going to have a YouTube live stream to celebrate a subscriber milestone in which we'll do a Let's Play of the role-playing game. So enough about what I will do, let's talk about what I have done. Let's get on with the code. And as always, if you have not seen the previous videos of this series, I suggest you do so. This is just going to be a direct follow-on from where the last video left off. And indeed, we left the last video at a position where we'd just implemented questing. We can go and talk to an actor in the scene, interact with them, and it starts performing some sort of quest activity. We go and talk to somebody else, and we're changing the behaviour of the game as we go along. So far for our role-playing game, we've missed out one fundamental element, and that's action. And indeed, this is trying to be an action role-playing game. So far, we've handled dynamic objects and questing. We can do fetch quests and we can give a story to our player, but other than exploration, there's very little skill involved in playing the game. And there's also very little consequence for getting things wrong. What we want to do is add an element of action to the game so the player has to make quick thinking decisions, and this is usually facilitated by the addition of enemies and weapons and items. Well, weapons and items are things that you carry and collect, and I think that's where we'll start. Let's add an inventory to our game. Right now we don't have anything that represents an item sensibly in our game code. We've got assets for sprites and maps and loading of things, that's good. And we've got commands, but they're not items or things you can carry around. And we've got dynamic objects. Now, it's very possible that dynamic objects may dispense items or consume items, but they are not in fact themselves items. This signals to me that we need an items class. And following the same pattern we've done for all other assets in the game, I'm going to create a base class called CItem, and each item is going to inherit from this base class to implement its own functionality. So we may have a health potion that heals 10 hit points, and we may have a health potion that heals 100 hit points. This behaviour will be encapsulated within subclasses. The constructor is going to take 3 parameters: a friendly name to identify the item, a sprite that tells us what the item looks like, and a description. This means I'm going to need some member variables that store that information. I'm going to store 2 additional flags. Key item is an item that cannot be used. It's some sort of item that might represent a role in a plot or a quest. And I'm also going to have a flag that signifies whether the item can be equipped or not, i.e. is the item primarily a weapon or an accessory? It's not just something you carry. I'm going to add 2 functions to the class. The first is onInteract, which we've seen a lot of in the previous videos, and this is going to be called when the dynamic object interacts with the item. Now, that's not the same as the second function that we're going to add, which is onUse, and this is called when the item is consumed. Now, you'll notice lots of red squigglies everywhere. That's because I've not included most of the definitions, but I can get most of those from rpgdynamics.h. So just to reiterate, onInteract is called when a dynamic object interacts with the item. That's not the same as when a dynamic object uses the item, i.e. consumes it. And in the CPP file, I've just added the implementation of the constructor. So let's learn how we're going to handle items by doing it. We'll create 2 items, 2 different types of health potion. Let's create 2 classes that inherit from item. First one is going to be item health, and we'll just put a little reminder here what that does. That's going to give the player 10 hit points of health. And you can see the class does nothing but override the onInteract and onUse functions. In a very similar way, I'm going to create an item called Health Boost. And this is going to raise the player's max HP by 10. Now, a health item may be something that's on the map, and this will predominantly be used when the player steps over it. He collects it off the map, it heals health. A health boost, on the other hand, may only want to be used when the player chooses to use it, so this is going to be an item that gets put in the inventory. So it's really just overriding the constructor is where we give it the name, its picture, and a description. So small health, we'll load a sprite called health, which looks like a heart, and we'll put in a description. In fact, we won't show 5, we will put 10 health there. Once we've constructed the item, I think the next most important thing to implement is what happens when the item is consumed, i.e. what is the item's purpose. And so this is going to be where we implement the onUse function. So this is the object that the item is going to be used upon. We're going to check if it's null pointer just in case. And I'm also going to assume that the object will always be a dynamic creature. Some of you may be frowning at this point, but I think it's a fairly safe assumption because the only thing that can use objects is the player. And in this case, if the player has used the object, whether the player has used it on themselves or another dynamic creature is a different matter, but we want to increase the health by 10, but at the same time cap it to the max health of the dynamic creature. And that's niftily done in this one-liner. And I'm going to start a convention that if the onUse function returns true, that means the item disappears. It gets removed from the inventory, it vanishes from existence. This way we can have items that we can use multiple times. It could return false. Now I also claimed when we were defining this simple item that it is something that will appear on the map. It'll be a heart shape that when the player touches, the player gains the health. That means we need to handle the onInteract function. So let's add that in. OnInteract, and again it's a boolean, but all the onInteract function is going to do in this case is simply call straight away the onUse function, i.e. this particular item is used straight away on contact. And if the onInteract function returns false, it just gets absorbed. If the onInteract function returns true, we're going to add it to a player inventory. So those 3 simple functions implement everything we need to know about this item. We know what it looks like, we know how to describe it, we know how to call it, we know how to interact with it when we touch it or use it, and we know how to consume it and what it does when it is consumed. We also know how using the item will manipulate our inventory. I'm going to do exactly the same for the health boost item. We've got the constructor that tells us what it looks like. There is no interaction with the health boost item, all it's going to do is return true, and that means we'll add the item to the inventory. At this time, when onUse is called, we increase the maximum health value of our dynamic creature object, and we'll remove the item from the inventory by returning true. So where is and what is this inventory you keep hearing me talk about? Well, let's have a look at our game engine. I'm going to add a list of C item pointers, and this will be our inventory. But I also want to add some convenience functions for handling things in the inventory. And in this case, I'm adding a give item, which will add an item to the inventory list, take item, which will take it away if it exists, and has item. This is to check does an item exist within the inventory list. I'll add these functions to the main engine class. Give item simply pushes the pointer to the back of the list. Take item checks to see if the item is valid first, and then does the find erase idiom to see if the pointer exists within the list and removes it. If the item was in the list, it now no longer is, and we return true. The item has been taken from it. In all of the circumstances, we'll return false. And the third utility function was, does the inventory have an item? And this is quite an interesting one, because this can be used by the questing subsystem to see if the player has a particular item in their inventory. And we can use this to gate the quests. I want to treat items like all of the other static assets in my game, so I'm going to alter my RPG asset singleton class to accommodate items. And you'll be more than familiar with the pattern by now. We're going to create a map which uses friendly names to item pointers, so we can easily extract the item pointer when and where we need it, no matter where and when we need it. I'm going to add a load items function, and I'm going to add a get items function. And in the CPP file, just like the other assets, I'm going to create the load items function, which will create a new instance of each type of item class. We do, of course, need to include our RPG items header file. I know that my items are going to need a sprite asset, so I'm going to modify the load sprites function to include those assets as they get loaded. So in this case, health and health boost. I think it's time to start testing the theory. How do we actually put items on the map? Well, of course, we're going to need a dynamic object that dispenses an item. Now, we have covered dynamic objects in every single video so far, but we've never considered what happens when the player interacts with a dynamic object. And so to the base class of dynamic, I'm going to add an onInteract function. I'll need to create a new dynamic object to dispense the items when the player interacts with it. And here I have such an object. It's got two functions which are overridden. One is draw self, which describes how the object should look on the screen, so that'll use the sprite. And here is our overridden onInteract function. The class itself only contains two items. One is a pointer to the item itself, and the other is a flag to say whether the item has been collected or not. And so to the end of my RPG dynamics.cpp file, I'm going to start adding in the dynamic item object definition. I want to store the location of the object, which is the location of the item on the map. I'm not setting any properties because I don't think any of them are particularly relevant in this instance, but I am storing a local copy of the pointer to the item. The drawSelf function is overridden, and it's incredibly simple. That just uses the sprite that we've passed through to it and draws it in the relevant location on the screen. The onInteract function is a little different. The first thing I'm going to check for is, has my collected flag been set? Because if it has, then I don't want to interact with the object again. I'm then going to call the item's onInteract function and pass along the pointer to the player. Once the item is used, it's been collected, so I'm going to set that flag to true, and that will disable it from being drawn and disable it from me collecting it again. I will add one more thing here, and it makes things a little bit more complicated. We did say that when the onInteract function returns true, it should be added to the player's inventory. Well, we need to get in touch with the game engine to do this for us, and so far we've not yet needed our dynamics to interact with the game engine directly. So in much the same way as we've done with script processing and other game engine interactions, I'm going to add a static variable gEngine to our base dynamic class. And we can call the giveItem function that we've just created to do the hard work for us. So in our dynamics header file, I'm going to add a static pointer to the RPG engine. And we must remember, like we have done with the other static assets, to link this in our onUserCreate function. Now, I did mention in the last video, when you start to see code being duplicated like this, there's probably another level of abstraction we can put in. I'm not going to do that right now, but I probably will do that before the code is released. Whilst I'm here, whilst I remember, I should also load my items into the asset singleton. So I will grab an instance of the singleton and call the loadItems function. I want to test the theory by adding the dynamic item object to our map. So in the populate dynamics function, I'm going to add items. Now, we may not always choose to add items, because right now every time the map gets loaded, we'll add an item to it, so it'll always be there. The player could health farm, for example, backwards and forwards between two maps. So we might want this to be conditional based on some more global map state. That's one of the reasons we put maps into a class in the first place, is the maps can change globally. Let's take a look. So I'll load the game, and we can see, indeed, a heart has now appeared at the correct location. But it looks like I'm not interacting with it, and that's because we don't yet handle interactions between dynamic objects. If we go to our main engine's collision code and check for the object versus object collisions, we did actually include an overlap checking routine last time, so when the player overlaps with an object. And in that event, the first thing we want to do is check, do any of the interactions for the quests, do they matter? Are we interested in that? Then the second thing we wanted to check was, well, was it a map interaction? Is it important to the map that that dynamic interaction occurred? Well, finally now, we want to see, does the dynamic object itself care about the interaction? So let's take a look again. We'll move the player over, and there we go. We collected the heart. The problem though was we couldn't really see if it did anything, so we need to display the player's health on the screen. At the end of the main render loop, I'm going to assemble a string that represents the player's health and max health. And I'm going to use our displayDialog function to draw that string to the screen. And if you remember, strings used in the displayDialog function are actually individual strings in a vector, where each string represents a different line. I'm going to draw that at, say, 160, 10. We'll see where that puts it. And very nicely the box has been sorted out for us. We've got 10 out of 10 hit points. Now problem is here, I can't see if that's worked because that's max health and we clamp the max health, so picking up the health doesn't go above what our max health should be. Therefore I'm just going to hack in a little debugging routine where I'm going to force the player's health to be 5. So now we can see the health is 5 out of 10. If we make the player walk over the object, it got increased. So the interaction worked. The health boost has automatically healed the player. I'm going to go back to the map function and add another item. But this time I'm going to add our health boost. And this is an item that doesn't work immediately, but it gets added to the inventory. So let's take a look. Well, we can see both items appear, so the health boost looks like a bottle. We know that we can't use it straight away, but we have collected it. Very nice. But how do we know that we've got it? We need to display our inventory to the player, and this involves a new screen. And I think this is quite interesting, because it's the first time during this development that we have to start considering game modes. It's time to make some really big changes to the RPG engine, but don't worry, they're cosmetically big rather than functionally big. I'm going to introduce the concept of modes, and this is going to decide what type of interaction is the player going to have with the game at any one time. For example, we may be at the title screen. We might be walking around the maps that you've seen in the video so far. We might be walking around a world map. We could be looking at the player's inventory, or we could be in a shop. Well, to start with, I'm going to assume we're looking at the local map. Now you might be thinking, hang on David, this is a series about object-oriented programming. Why aren't we using classes and base classes to do the same thing? And you'd be right to think that. We could easily create a subclass and override the onUserUpdate functions as necessary. However, I'm a believer that object-oriented programming is only necessary when it's necessary. And in this instance, it isn't, because in my onUserUpdate function, I'm simply going to check what my game mode variable is and call an appropriate function that represents the game at that point in time. So all of the previous code underneath here doesn't need to change at all. We just need to change the name of the function. So in this case, if the game mode variable is update local map, it calls the code that we've been doing so far with no changes. I'll need to add these functions to the header file. There we go. And that's very nice. Without needing additional classes or additional files, we've managed to get a dynamic behavior depending upon the game mode variable. So with our new mode, we can have a mode which is update inventory. We can display a menu to this player. And it has a side effect that none of the background game variables change during this phase. The menu acts like a pause. And we've not had to add any additional code to facilitate this. So in many respects, we can treat update inventory as if it was a brand new game. And the first thing I'm going to do is clear the screen and draw with big text inventory at the top of the screen. For my inventory screen, I'm going to represent all the items that the user has collected so far as a matrix, and I'm going to need to store some X and Y coordinates to know where the player's cursor is within that matrix. I'm going to use a little for loop to iterate through all of the items in my inventory list. It'll generate some coordinates based on the position of the item within the list, and draw the item on the screen, using the sprite that's contained within the item from our asset singleton. I'll need a couple of temporary variables to help me out here. I know my matrix is never going to contain more than 16 items. This is an element of game design rather than function. And as I'm drawing the items, I'm going to check that the coordinates match up with the player's cursor coordinates, and if they do, that's my highlighted item. I can store a pointer to that. I want to give a visual indication to the player that that's the item they have selected. So all of this code here simply draws a rectangle around that item. Now don't forget, this is like any other onUserUpdate function. It's being called every single frame. So it's at this point I also want to check for user input on the menu screen. I'm going to use the cursor keys to move my cursor around. Depending on what the user has highlighted, I need to decide what information to display on the screen. And so I'll make sure that the highlighted pointer isn't null, and then I'll draw the item's name and I'll draw its description. But I'm also going to check user input for the spacebar, and this will mean use the item that's currently highlighted. Now, we decided that key items can't be used. So if it's not a key item, it must be some sort of consumable. So we'll use the items on use function on the player to see does it indeed get consumed. and if it does, we'll take it away from our inventory. We'll come back to key items later on. Whilst I'm in a menu screen, I'm also going to display some other information, the current location of the player and the current health status of the player. Now we need to add a facility for the player to actually access their inventory. I'm going to use the Z key for this. One of the reasons for not using a complex object-oriented tree to represent game states and modes is to change mode now becomes very simple. I simply set it. And so if I'm in the inventory screen and the user presses the Z key, I'm going to return to the local map screen. However, in my update local map function, I've got the standard user input here for controlling the character direction. I'm going to add in, if the user presses the Z key, we enter our inventory mode. Simple as that. Let's take a look. So let's see. Here is my character. Now if I press the Z key, it brings up the inventory screen, and I can move my cursor around. I have no objects in my inventory at the moment, so I'll press the Z key again to go back to the game. I'm going to try picking up the health boost. Well, it's disappeared, so that signifies that I collected it. If I go to my inventory, indeed there it is, and if I put my cursor over it, I can see the properties of the object I've just collected. Press space to use. So, it's not using it. Let's just take a quick look. Well, if I look at the code here, what I can see is if my item is not a key item, I've put this in the wrong section. Let me move that over. So I've picked up the item, press space to use, I've used it, it's disappeared from the list. I didn't have to write any code to make it disappear because the inventory is updated on every single frame. It just checks whatever's in that list. And you can see my max health has increased to 20. I have nothing left in my inventory. I may as well come out of it. And we can test the inventory a little bit here by basically farming health potions, because we knew that we would add them to the map each time the map was loaded. So I've collected 4 of them. Very nice. 1, 2, 3, and 4. Lots of health. Just before we move on to the exciting combat phase, let's have one last look at items and how they can be used with quests. In the last video, Syrah was the character outside, and we had our main quest where you could interact with Syrah and you'd get a different response, depending on how many quests you had in your quest tree. So, to just debug the items, I'm going to leverage this particular quest. So instead of saying you have no additional quests, what Syrah is going to do is check to see do you have an item in your inventory or not. And so when that interaction occurs, the first thing I'm going to do is call the hasItem function, and I'm going to look specifically for a health boost in this case, because that's the only item I've got that I can collect. If I have got that, then I'm going to display something along the lines of, well, you have got a health boost. So Syrah will say, wow, you have a health. Oh, we'll just stick it on the next line, why not? Boost. If we haven't got one in our inventory, then we'll say something else. Boo. You don't have a health boost. It's original. Let's take a look. So I'll talk to Syrah. I don't have a health boost, I've not picked one up. Boo, you don't have a health boost. And I didn't quite fit it all on the screen there, but it was the message that we were expecting. Now, I will go and pick up a health boost now. There we go. I'll make sure it's in the inventory. It is. Let's go and talk to Syrah. Woo, you have a health boost. And we can see that this is actually now a very powerful tool indeed. We can control the quests via the objects that the player finds and collects. Right, now we're up to the bit I've been dreading the most, but is arguably the most interesting part of this whole series, combat. And I want to consider combat to be an interaction between two dynamic things that aren't friends. But I don't want the combat to be a fairly boring melee affair, where everything is based on swords and spears and being next to the player character. I want the combat to be a little bit more exciting. I want to include bows and arrows and fireballs, magic spells, projectile-based weaponry. And so I need a system that's flexible enough to handle both types of combat. And as usual, I'm going to reduce it to its utmost simplest for me to implement, yet yields the most compelling form of gameplay. I'm going to assume that all attacks are projectile attacks. So even a melee weapon attack with the sword will appear on the screen, we're still going to treat it as a projectile. And if that projectile overlaps with, say, an enemy, an interaction has occurred, at which point damage is inflicted to the enemy, based on whichever weapon or item the player is carrying. So the projectile is in some way intrinsically linked to the items. And this introduces a further problem. Currently, we always know how many dynamic objects we've got in our scene. Projectiles are dynamic objects that we may have a multitude of them, and it varies depending on what's going on in the game. So we want to treat them a little bit differently. However, we want to reuse all of the code we've created for the dynamic objects so far. As you can see, this is going to be quite a complicated topic, but I'll try my best. Let's start by adding a new type of dynamic object, the dynamic projectile, which is simply a sprite that moves around on the screen for a given duration. And we also want to see how many dynamic objects can the projectile hit before it disappears. So if it hits one thing, it disappears straight away if the one hit flag is true. However, if it's not true, the projectile will exist for the total duration. As usual, we define the projectile via its constructor, we get it to draw itself, and we update its behaviour by overriding the update function. I'll add the body to the dynamic CPP file. And for the projectile, I want to take in a starting position, X and Y. I want to specify whether the projectile is friendly or not, i.e. was it cast by the player or was it cast by a creature. I also want to specify a velocity for the projectile. It's going to move in that direction for the given duration. And I also want to specify the sprite sheet, the asset, what does the projectile look like on the screen, and because I think all of my projectiles are going to be grouped to make it convenient, I'm also going to specify a tx and a ty value, which is going to index into the sprite sheet to give us a particular location. Now there are some additional variables in here. As well as setting all of the standard dynamic object things, I'm also going to have two flags. Is it a projectile and is it attackable? And these are flags that don't exist yet because I'm going to add them to the base class of my dynamic object. The isProjectile one should be fairly self-explanatory. Is the ultimate subclass actually of the type projectile? We don't really want to do any runtime type checking to work that out, so we're just going to store a Boolean flag. The isAttackable one is a little bit more strange. This is going to suggest that the dynamic object is capable of receiving damage. It can be attacked. Now, because I've altered a base class, I'm going to have to make quite a number of changes to anything that inherits from these classes to set these variables accordingly. Fortunately for us, in most cases, these are set to false. But the dynamic creature type is attackable. So we'll set that to true. And as you can see, the update function does very little. It just maintains this fDuration variable, decreasing it with felapsed time. And if the duration goes below 0, it sets a flag beRedundant to true. And any dynamic objects whose flag redundant is true will be removed from the vector of dynamic objects maintained by the game engine. In the items source file, I'm going to subclass my base class CItem with a special class called CWeapon. And all this does is store the amount of damage that that particular weapon does. In all of their attributes, it's exactly the same as a regular item. And so if I want to create specific items, I do so by subclassing my CWeapon class. In this case, I'm going to create a basic sword. And the only function I care about with my sword is the onUse function. If we go over to the CPP file for items, the weapon class does very little. All it does is cache this damage value, but it gives us this weapon interface, something that's discrete and different from items. But we can leverage all of the item properties to make it appear in our inventory and make it collectible and interactable. Using our item structure already, we can very easily now create additional types of items specialized as weapons. So we already defined our basic weapon here. This is the constructor for it. We'll call it basic sword. We'll give it the sprite basic sword. We give it a description and we give it the damage. In this case, it'll do 5 hit points of damage. We will also need to implement the onUse function for that weapon. And when you use a weapon, we don't want to remove it from the inventory, so it's going to return false. We'll come back to the weapon in a minute. Let's handle how the player actually performs an attack. So in the engine header file, I'm going to add the function attack. This takes 2 parameters. The first is a pointer to the dynamic creature, which is the aggressor, the person or thing conducting the attack. And the second is a pointer to a particular weapon, the weapon used during that attack. Very simply, all that happens in this function is that the weapon's onUse function is called. Now, surprisingly, we don't use the weapons on the thing we're attacking. We use the weapon on the aggressor. And this could be we want to modify the weapon's behaviour based on the status of the aggressor. For example, in the original Zeldas, if you had full health, you could have beam sword instead of just regular sword. So this facilitates how the weapon is used, not who the weapon is used upon. And don't forget, as I mentioned before, the weapon doesn't perform the attack. Projectiles perform attacks. So now we need to get the weapon to spawn a projectile into the game engine and have the projectile move in such a way according to the weapon. So if it's an arrow, it'll fly in a straight line. If it's magic, perhaps it swirls around the screen. And if it's a sword, it just appears there. So let's run with the sword as an example. We'll go to the Swords on Use function and we'll determine something about the properties of the aggressor. In this case, it's just a basic sword being used, but I need to know which direction is the attacker facing in order to draw the correct sprite on the screen. I don't want to draw the same sprite for all 4 directions. I want the sprite to be reflected and rotated accordingly. So now I know which aggressor is about to cast a projectile into the scene, I can determine what information I need as to how I put that projectile into the scene. So here I'm grabbing the attacker's position in world space, but I'm offsetting, so I don't want the projectile to start where the player exactly is. I want it to appear to the left of the player or to the right of the player. And this is where things may get a little bit tricky. For now, what I'm going to do is create a projectile. See, dynamic projectile, it's allocated with new. We give it the starting coordinates. We specify is it friendly or not to the player or to the enemies. And given it's a standard sword, I'm going to give it the same velocity as the player is currently moving with. So that way the projectile won't stand still when we add it to the scene, it'll move along with the player. It'll look like the player is carrying the projectile. I'm also specifying the duration, so it's only going to appear on the screen for 1/10 of a second, a brief flash, which will look like the sword is being swiped at the enemy. And of course, I can specify what graphic I want to display. And you'll see this little bit of magic at the end. This is just to index my... This is just to index my sprite sheet accordingly. I've basically got a sprite sheet with 4 swords, one facing north, south, east and west, and this one chooses the appropriate one based on the direction the player is facing. But I want to add some additional properties to my projectile that make it unique to being the basic sword. I'm going to say that it is not solid versus the map. I'm going to say it's not solid versus dynamic objects. Don't forget the projectile itself is a dynamic object. It's going to obey the laws of physics in our game engine. In this case, I don't want anything to get in the way of me swiping that sword. I also need to specify how much damage the projectile is going to inflict when it actually hits the target dynamic object. And it's only going to hit one thing before it's removed from the list. Now I have customized a projectile unique to this weapon. I'm going to add it to the game engine. And this of course means we need yet again to implement a static linking towards our game engine itself. I'm not going to show how to do that again. Now we need to add to the game engine the add projectile function. And this in itself is nothing particularly special. Along with my vector of dynamic objects, I'm going to have an additional vector, which is my vector of projectiles. Now these are also dynamic objects, but there is a difference. The original ones, they're always fixed. These get changed depending on the quests and the maps. Whereas the projectiles, these are transient. I want them both to obey the laws of my physics engine, but I don't want to have to duplicate all of the code. Let's go to the bottom of the engine file. At the bottom of the engine file, I'm going to add my add projectile function. As you can see, all it does is push the pointer into the vector. But all of this physics and drawing code is completely valid for both vectors of objects. How can I handle both vectors at the same time? And this is where we're going to use some modern C++ in all of its glory. I'm going to wrap our existing for loop in an additional for loop, and I'm going to call the identifier source, and this source is going to be of the type pointer to vector of dynamic objects. I'm going to wrap all of my code in that. Go all the way down here. There we go, and go back up. So this will allow me to switch between one vector and the next. So instead of choosing vector dynamics directly for the object, what I want to do is choose the value of source. And this will effectively glue together the two vectors in a non-destructive way. Both vectors still maintain their original identities and don't interfere with each other, yet I'm treating them as if they are one big vector. I will add a little flag. I feel it might be useful later on, so I can identify which vector I'm working with later on in my code. So to begin with, I'm not working with projectiles, but one iteration through the loop. I'll find the bottom of it down here. Now I am working with projectiles, so I'm going to set that to true. I've got a feeling that might come in handy. We also have the same thing here for getting dynamic objects to update themselves. We want the projectiles to update themselves. So I'm going to put in very similar code. And additionally, when we get the dynamic objects to draw themselves, well, that too uses similar looking code. And I like this approach because I can play about with the projectiles vector without upsetting my dynamic objects vector. Now at the start of my update local map function, I'm going to check my vector of projectiles to see if any of them have been flagged as redundant, and if they have, I'm going to remove them. Now I think we're almost ready to start handling the attack, and we've already decided that an attack is going to be instigated by an interaction that doesn't yield anything useful. So the player isn't interacting with the scenery or an object or an NPC, the player is just pressing the interact key, in this case the spacebar. And we already have a clause down here which says interaction was with something not friendly, only enemies are not friendly, so perform the attack. And we also know that if we get this far and we've not hit something, our hit something variable was set to true, if any of this sort of stuff revealed, yes, something interesting has happened, then that should also just be treated as an attack. But what is an attack in this case? Let's use object-oriented programming yet again to make it that we can have attacks unique to different characters. If we look at our dynamic creature class, we already see that it's capable of quite a lot, including AI, and one of those AI decisions may be to perform an attack. So I think our dynamic creature object needs a function perform attack. So I'm going to add that in as a virtual, so it's going to get overridden by any subclass dynamic creatures that we create, and including one of those is the player character, Wittybit. Now, of course, a dynamic creature may also be able to carry with them a weapon. So we'll have a pointer to a weapon, equipped weapon. And of course this is our base class C weapon, so it doesn't really matter what derived class weapon we've got, we know we'll be able to store it in this location. Now we created in the past an enemy character called a Skelly, so we'll have to override the perform attack action for the skeleton. So that's going to get called when the skeleton decides it's going to do an attack. Let's additionally add a dynamic creature class called Witty. This is going to represent the player. In the code up until now, we've just created the player explicitly. Now it's time to give the player its own class. So I'm going to start Witty off with a health of 9 and a max health of 10, and I'm also going to say that the equipped weapon is going to be grabbed from our asset singleton, and it's going to be called basic sword. Now don't forget, weapons are just items. We've already made this code. And when Witty, the player character, decides to perform an attack, we're going to see, is the weapon that is equipped currently null pointer? If it is null pointer, then we don't want to do anything. There can't be an attack. But if it isn't, we're going to use the equipped weapon. So let's follow this through. We call an interaction in the game engine, which calls perform attack on our player character. Our player character is equipped with a basic sword. We call the onUse function of our basic sword, but label the dynamic object as being the player. On our basic sword class, here it is, onUse, we notice that the player has gone through as the aggressor. The aggressor properties have been determined. The weapon has then chosen the correct projectile and nature of projectile to display, and adds the projectile to the game engine. The game engine then treats that projectile just like any other dynamic object in the scene, except it's transient. It can be removed. And so once we've got the projectile moving through the scene, we can look for object versus object collisions. And we can then determine, has a projectile overlapped with an object? So here we're going to deal with an interaction between two dynamic objects. And we know if we're in the working with projectiles phase of our loop, then one of those objects must be a projectile. In that case, we check to see, have we overlapped? Do the projectile and the object that it is overlapped with have opposite friendly status, i.e. can they hurt each other? Is the target of one of these objects, is it attackable? Is it a creature? Is it something that can be damaged? And if it is, after all of this, we can call a damage function to inflict the damage on one of our dynamic creatures. And here it is. I'll add in the damage function to the header file, and I'm just going to add it in as a placeholder to the CPP file, because we've written a lot of code with a lot of interaction so far and not got around to testing very much of it. And now we can also call our perform attack function when the player interacts in the appropriate manner. So let's take a look and try and understand everything that we've just done. So here we've got Witty, and I'm going to go to an empty space so we're not interacting with anything, and we can see a sword appear and disappear very briefly depending on which direction Witty is facing. And this is the projectile entering and exiting existence because we told it to only exist for 1/10 of a second. What's more is that the projectile moves at the same velocity of the player, so as the player is moving around, the sword looks like it's always being held by the player. Even better is we can see that the sword exists in our inventory, so it is something equipable and it's got a description. Let's just for fun quickly hack in a beam sword. Now before you all think, oh no, we really got to sit through all that again, no you don't, because actually implementing a beam sword is very simple. We just go to our standard sword implementation, and instead of just attacking with a static projectile like this, we're going to add an additional projectile if the aggressor's health is equal to the aggressor's max health. Aggressor n health is equals to the aggressor's health max. If it is, then we're going to throw out an additional projectile, and we'll just call that the beam sword. So we create the projectile in exactly the same way as we did before, except we choose a very slightly different graphic. I want the duration to be 1 second long on the screen. I'm also going to say that the beam sword is solid versus the map. I don't want it to pass through trees and buildings. But it's not solid versus other dynamic objects. It's also not a one-hit wonder sort of weapon. It will keep on going and hit things beyond the first thing it hits, but it'll deal the same amount of damage. Let's just see if this works. So you'll notice my health strategically, do you see how all this comes together, is a 9 out of 10 at the moment. And I'm not casting a beam sword when I attack. However, I go and pick up this heart and bring myself to full health. I'm now throwing out a beam sword. What we'll notice though is it's sort of sticking. The objects are not getting made redundant quick enough. And this is because we're doing dynamic versus dynamic interaction checks, including the projectile list, but we're not doing any dynamic versus solid interaction checks when working with projectiles. So for all dynamic objects, I'm going to add a Boolean flag, which we're going to set to true if the dynamic object has interacted with the static background map. So we'll set it for west, we'll set it for east, we'll set it for north, and we'll set it for south. And now we can see that if we are working with projectiles and we've collided with the map, I want to set the object to be immediately redundant. So it should disappear straight away. We'll just try that out. Full health, beam sword, disappears now whenever it hits a static object. Perfect. I don't think beating up Sura all the time is particularly very sporting. So I'm going to make our Skelly creature have an AI routine which is to attack the player, when the player is close enough. So in the Skelly's behavior function, I can update its AI that when the skeleton is close enough to the player, we're going to say 1.5 cells away from the player, it's going to call its own perform attack function, which is just the same. Uses the equipped weapon and it calls the attack. But we need to equip Skelly with the weapon too. So we'll set this dynamic creature's object's equipped weapon variable to also a basic sword. And we'll bring back in some old code from a couple of videos ago where we had skeletons. There we go, 3 skeletons, and we'll see, do they go for the attack? And you can see, there we go, straight away. And of course, because my skeletons have full health, they use beam sword. Right now though, we're not actually casting any damage. So let's populate the damage function. First thing I'm going to check for is just to make sure that the victim isn't null. And from the victim's health, we want to take away the damage caused by the projectile. We know that due to object-oriented programming, that the victim object will handle the going below 0 health in its own way. At this point, we'll also check what the one-hit status of the projectile is, because if it's hit something and damaged it, and its one-hit flag is set to true, then the projectile is defunct, it's expired, it's used up, we must get rid of it. And I'm also going to add something here for quest reasons. What happens if an NPC is set on the map, although it's an enemy NPC, it's not attacking you, but you've chosen to attack it. So if the victim is not the player, then I'm also going to call the onInteract function for the dynamic object and tell the dynamic object it's just had an interaction from the player. Most enemies will just choose to ignore that, but we may have an NPC that triggers the start of a battle or a cut sequence or something else. But I also want to add one final thing just to make the combat a little bit fun. I'm going to add the ability to get knocked back in combat. You might remember from the original Zelda games that whenever Link damaged an enemy or got damaged himself, he would be sort of tossed backwards or in a particular direction opposite to where the enemy was coming from. And this served two purposes. One is it made the combat a little bit more risky because you didn't know where you were going to get kicked to if you got hit. It might kick you down a pit or onto some spikes or into another trap. But it also served as a way of stopping the player from being overwhelmed with attacks. Once you've flicked an enemy out the way, it's away from the player. It's not immediately going to melee attack again. So it serves a bit of a dual purpose. And it turns out knocking back the victim does require a little bit of code, but it's all within the realms of our physics engine. So I'm going to work out what the distance is from the projectile to the victim. And I'm just going to make sure that we don't end up with some divide by zero errors here. So I'll just make a check that that distance is less than 1. I think knockback is a required enough function that it's going to get its own function as part of the dynamic object class. And the arguments to the knockback function are the normalized direction vector components plus a duration. How long should the knockback effect be in place? And so to the dynamic creature class, I'm going to add my knockback function. I'll also need some member variables to store information about the state of the knockback effect. We could potentially even have additional graphics to represent the character being knocked back, but I'm not going to implement that today. There is one more important boolean to add here, and that is during knockback, technically there is no player control. So I want to have a flag that says, is this dynamic object actually controllable at this moment in time? And by default, I'm going to set that to true. Now the knockback routine will apply to all dynamic creatures, so that's why I'm adding it to the base class. I don't need to add it individually for the skeleton and the player character class. And the knockback function is going to cache the direction of knockback and the duration of how long that direction should be travelled along. I'm going to set the solid versus dynamics object to false, and the reason for this is once you knock something back, I want to be able to knock back an object through other objects that might be behind it, but I don't want to knock it back through solid objects such as the map. During the knockback, I don't want any control over the character, and nor should the character or player be attackable. It is a moment of respite. You've just taken a hit. I don't want you to suddenly be swamped with more and more hits. So by setting the is attackable value to false, you effectively it's invulnerability frames. And this means fundamentally the only change we need to make now is in our update function to the dynamic creature. We have to handle the effects of knockback. So all of this code assumes that we are not being knocked back. So I'm going to say that if my knockback timer is greater than 0, then I am in my knocked back state, else I am functioning exactly the same way I always have done. I'm going to set the object's velocity to be quite quick and proportional to the direction. Remember, these come through pretty much normalized. And I'm going to decrement my knockback timer variable by f elapsed time, and if this goes below 0, we're no longer in the knockback state, we're back in normal operation state, so the object is both controllable and it becomes attackable again. Now in the knockback function we just created, we specified that the solid versus dynamic object should be set to false, and we want this to be the case for everything except the player. We never want the player to be able to go out of bounds. And so in the engine, I'm going to call the knockback function, and as I'm already checking here to see is the victim the player, but if it is, I'm going to set the solid versus dynamics to true. So even though this may have just set it to false, I'm immediately setting it to true again if the object happened to be the player. Now for one last time on this big project, let's take a look. And here we go, and we can see we've got some additional Sedit slimes added into the mix this time. You always want to avoid the Sedit slimes. They're quite friendly. Oh, hang on, beam sword. See how I got kicked out of the way there? And I've been killed already. However, I can still animate my corpse. So I'm going to go and have a look around here, and I can still attack. What I should probably do is use some health. Let's check my inventory. Have I got something in my inventory? I've got a health potion. I can give myself maximum health here. It's brought me back to life. Let's just get some of these slimes out of the way. Oh, got hit by a beam sword then for an enemy skeleton. Let's just try and take the skeletons out. There we go. They've died. And another one. Final one. Let's pick up some health. Need that. Sedit slimes are getting in the way a little bit here. Oh, picked up a health boost. So, I've entered this building. I know I've got some plot in there from a previous video, but did we also implement a switch here? We've got a switch that enables the rain. Oh, that's very nice. Wasn't expecting that. And we got, oh, flash of lightning there. Let's just turn off the rain for a minute. And we've got some interactable door here. We've got One Lone Coder operating system version 1.0. That's interesting. I think we'll turn the rain back on and go back outside. Oh, the rain isn't persistent. That's a shame. Never mind. And that's that. There you have it. After 4 long videos and lots of code, that's how to code it yourself role-playing game One Lone Coder style. Thanks for putting up with all of this big project code stuff. I know it's not to everybody's tastes, but sometimes the bigger projects allow me to do a lot more interesting things and work with more interesting code. I've decided I won't be doing any more programming videos on this topic, but what I will do is release the source code along with a small demonstration game that takes about half an hour to complete. And this game will have cut sequences in and special effects and a boss battle and a few different maps and dungeons to explore. I think that's a much more useful way to learn about how the code works and is put together. I'd like to take this opportunity to thank lots of members of the Discord community who have created the graphics and the tools and the utilities required to make this project happen. I couldn't have done it without them. And so I really recommend that you get involved with the Discord community if you want to take on some of this RPG development for yourself. Hopefully the Discord community are going to take this code and create their own unique role-playing game with it. We'll see how that goes in a future community showcase perhaps. Anyway, it's been a long series. If you've enjoyed it, please give me a big thumbs up. Have a think about subscribing if you haven't already and you're 4 videos in and they've been an hour long each. Then thank you very much for coming back each time. Take care. The source code will be available soon. I'll see you next time.